Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 21 to 27 of the June 2015 Algebra 2 Trigonometry Regents exam. All right, let's take a look at problem 21. It says, what is the inverse of the function f of x equals log base 4 of x? Okay, so we have f of x equals log base 4 of x. So if you want to find the inverse, there are two steps. First of all, you rewrite the function using y, and then you're going to switch x and y and solve for your new y, okay? I call it switch and solve. So first of all, let's rewrite. If we want to rewrite this equation, we're going to have y equals log base 4 of x. It's called as rewrite. And then after you rewrite, step number one, you're going to switch. Okay, what do I mean by switch? You're going to switch the x's and the y's. So if you switch the x's and the y's, you have x equals log base 4 of y. Okay, and then you're going to solve for your new y. That new y that you're going to solve for, guess what? That is your inverse. Okay, so how do I eliminate log base 4? The inverse of log is exponent base whatever the base of the log is. So this is log base 4, so an exponent with a base of 4 is the inverse of this. So what I'll do is I'll exponentiate both sides using 4 as the basis of my exponentiation. Okay, so you have 4 to the little x equals 4 to the little log base 4 of y. All right, this cancels out, and we're going to have um, y equals 4 to the x. What is this y? This y is the inverse. So f inverse of x is equal to 4 to the x power. The answer is option number 2. All right, let's take a look at number 22. It reads the expression 1 plus cosine 2a over sine 2a is equivalent to. So the one thing you want to note here is that the argument of the cosine and sine function are doubled. Okay, so you have cosine 2a and you have sine 2a. So if you take a look at your reference sheet, what you will want to focus in on are the double angle identities. So I extracted them over here for your viewing pleasure. Okay, so I'm going to start with the denominator. Sine 2a is the easiest to work with since there is only one double angle identity for sine 2a, okay? So let's rewrite the problem. We have 1 plus cosine 2a divided by sine 2a. The bottom can be rewritten using the double angle identity as 2 sine a cosine a, okay? As you can see here, 2 sine a cosine a. Let's go ahead and write that down. So we have 2 sine a cosine a. Now 1 plus 2 cosine a, we can just focus in on the double angle parts. So cosine 2a, we have three options here that we can use. So I'll select the second option, because if I select the second option, 1 will cancel with this 1. This negative 1 here will cancel with that 1. And then I can break 2 cosine square a up and cancel one of this, and I'll be able to use the quotient identities for my final results. All right. So let's go ahead and do that. We have 1 plus, instead of cosine 2a, we have 2 cosine square a minus 1, the double angle identity for cosine. All right, so let's go ahead and simplify that. We're going to have 1 plus 2 cosine square a minus 1 divided by 2 sine a cosine a, okay? Now, what you notice happening is 1 and negative 1 are opposites. They add up to 0. And I can express the top as a product of two trig functions, cosine a times cosine a. That is what cosine square a is. that divided by 2 sine A cosine A, okay? Now, the beauty of writing it in the expanded form is you can cancel with ease. So that goes there once, that goes there once. The 2's also divide out. Now, using your quotient identities, what is cosine over sine? Cosine over sine is cotangent. That's the reciprocal of tan, okay? Cotangent A. Our answer for 22 is option number 1. All right. 23 reads, a video streaming service can choose from 6 half-hour shows and 4 one-hour shows. Which expression could we use to calculate the number of different ways the service can choose 4 half-hour shows and 2 one-hour shows? Two things you want to remember when dealing with permutation and combination and selection problems is whenever you're choosing without any order, that's combination. Okay? Think about C for choose and C for combination. Whenever you're placing or placements or arranging, anything that has to do with order is permutation, okay? All right, so this mnemonic device, this pattern helps you determine what to use. Is it permutation or combination? Another thing you want to remember is whenever you have and, the operation is multiplication, okay? So and is multiply, okay? Times, and or is add, okay? So let's write it out so you don't get confused. Multiply, and then or is add, okay? So in this problem, first thing you want to notice is that you're choosing without any particular order. There's no order here, okay? No order. So is it permutation or combination? It's combination, okay? So eliminate options 1 and 2. It cannot be any of those. Now you have 4 half-hour shows and. So what operation is and? Operation is multiply, multiplication, okay? So we're going to do combination and multiplication. You can clearly see that our answer is option number 3. Out of 6, you choose 4 for the 4 half-hour shows, and then out of 4, you choose 2 for the 2 for the 1-hour shows, and then this and the multiplication is and. If it were or, your answer will be option 4. Okay, so our answer for this is number 3. All right, let's take a look at problem number 24. It says the roots of 3x squared plus x equals 14 are. So to describe the roots of a quadratic without actually solving it, what you use is the discriminant, okay? So the discriminant is a powerful tool to predict what the nature of the roots are without even solving the problem, okay? So the discriminant is known as b squared minus 4ac. This is the radicand of the quadratic formula, all right? Okay, so let's go ahead and find the discriminant here, but note that before you use the discriminant, your equation must be in standard form. Does that rule sound familiar to you? It should, because remember, before you use the quadratic formula, your quadratic must be in standard form. Okay, so do not forget that. So let's put this in standard form. Basically, terms with descending degree equal to 0. So we have 3x squared plus x minus 14. Please do this first before you find a, b, and c, okay? A is 3, b is 1, c is negative 14. Now we're going to compute the value of the discriminant, all right? And then that result will help us describe what the nature of the roots are, okay? So we have b squared minus 4ac. We want to evaluate this expression using these values. So if we do that, we're going to have 1 square minus 4 times 3 times negative 14. Please, please, please always use parentheses. It's for your own protection. Prevents you from making errors with signs and order of operation, okay? So let's simplify this. If we do that, we'll have 1. This minus times this minus makes this a plus. Times 4 times 3 is 12 times 14. If you plug that in your calculator, you get 169. Okay, so now just looking at this number, we can predict what's the nature of the roots of this quadratic is going to be, okay? So first of all, if it's negative, then it's going to be imaginary. Is this number negative? The answer is no, so it cannot be imaginary. So it's real, okay? Now, if this number is not a perfect square, then it's going to be, the roots are going to be irrational. Is 169 a perfect square? It certainly is, because if you calculate the square root of 169, what is the square root of 169? It's 13, right? Square root of 169 is 13. So this is a perfect square. So if it's a perfect square, that means the roots are rational, so it cannot be 4. Okay. Now, how do you know if they're equal or unequal? Well, if this number is equal to 0, then it's equal. That's known as a double root. So is this 0? The answer is no. So since it's not 0, they cannot be equal. So we have to eliminate option 2. So based on this result, a positive perfect square tells us that the roots are going to be real, they're going to be rational, and they're going to be unequal. Okay? So the answer is option number 3. All right, let's take a look at 25. It says circle O has a radius of 2 units. An angle with a measure of pi over 6 radians is in standard position. If the terminal side of the angle intersects the circle at point B, what are the coordinates of B? Okay, so when you think about coordinates, you're looking for the x and y value. All right, so let's go ahead and set up the system. This is a coordinate system here. Pi over 6 is in the first quadrant. Remember, pi over 6 is the same thing as 30 degrees, okay? So that's the point. All right, so this is the bigger circle with the radius of 2. So if the radius is 2, we have 2 here. Now, if you have a point in standard position, what you have is a nice right triangle, okay? The angle here is pi over 6 or 30 degrees, same thing. And we're asked to find the coordinates here, x, y. All right. So how does this coordinate apply to this right triangle? This side right here, the side that's parallel to the y-axis, that's y units long. And then this side right here is x. Okay. This problem can easily be solved using Sohcahtoa. All right. We just pick the right ratio to use, and then we can solve the problem. So the ratio that you're going to use depends on what you want to find. Do you want to find x or y? The cool thing about this problem is all the x values are unique, the same with the y values. So just by finding one coordinate, you can determine what the correct answer is, okay? So how about we go ahead and find x? If I want to find x, I'm going to use my radius and x. So relative to this angle, this is the opposite. O in Sohcahtoa, this is the hypotenuse. H in Sohcahtoa, and this is the adjacent. A in Sohcahtoa, okay? Since we want to find x, we're going to use A, which we need, and H, which we know. All right, so which trig ratio has A and H in it? Ka, right? Ka in Sohcahtoa. So we're going to do cosine of the angle, which is pi over 6, is equal to adjacent over hypotenuse. Okay, so now we're going to solve this equation for x. Recall cosine pi over 6 is the same thing as cosine 30, which is equal to root 3 over 2. So we're going to plug in that value here for cosine pi over 6. So we're going to have root 3, let's change the color, root 3 over 2. Root 3 over 2 is equal to x over 2. To isolate x, you multiply both sides by 2, and your final answer is root 3. Okay, so the x-coordinate of that point is root 3. We can clearly see that our answer is option number 2. All right, let's take a look at number 26. It says, what is the value of the discrete sum from 0 to 2 of 3 minus 2a raised to the x power? All right, so you really want to understand what this notation is asking you to do, okay? So this symbol, sigma, means to add, okay, or find the sum. X equals 0, this is where you start. That's a starting index. And then this value right here is where you stop. All right, what do I mean by start and stop? This value x is going to be taking on integer values from 0 to 2. And then you add up all those distinct values, all right? So x is going to be equal to 0, is going to be equal to 1, and then it's going to be equal to 2, resulting in 3 expressions. And then we're going to add all 3 of them because of the discrete sum, okay? So let's go ahead and do it. When x is equal to 0, you have um, 3 minus 2a to the what? To the 0th power, which is equal to 3 minus 2a. When x is equal to 1, we have 3 minus 2a to the first power. Well, I just made a mistake. If you raise this to the 0th power, the entire thing becomes 1. So let's erase that. This whole thing is 1. Sorry about that. And then this is what I was talking about. So 3 minus 2a to the first power is just 3 minus 2a. We can go ahead and add these two while we're at it. So if we add these two, we're going to have 4 minus 2a. All right. And then when x is equal to 2, we're going to have 3 minus 2a to the second power. Okay. So what is 3 minus 2a to the second power? That's equal to 3 minus 2a times 3 minus 2a. Okay. All right, so let's FOIL this out. So if we FOIL this out first, outer, inner, and then last. Remember, we're still dealing with x equals to 2. So if we do that, we have 9 minus 6a minus 6a plus, don't forget minus times minus is plus, plus 4a squared. So that's 4a squared minus 12a plus 9 in standard form. So what are we going to do with this? We're going to add it to the sum of the first and second iterations of x, okay? So the sum of x equals 0 and x equals 1 is 4 minus 2a. So we're going to do, so let's go ahead and combine like terms. So we have 4 minus 2a, the sum of the first two, plus 4a squared minus 12a plus 9. Okay, so let's see. 4a squared is the only square that there is. Bring it down. Minus 2a minus 12a. You add and keep the sign minus 14a. And then positive 4 plus 9 is plus 13. Your answer is option number 4. All right, let's take a look at 27. It says the population P of x of wild turkeys in a certain area is represented by the functions P of x equals 17 times 1.15 to the 2x, where x is the number of years since 2010. How many more turkeys will be in the population for the year 2015 than 2010? Okay, so let's start with the year 2010. What is the population there? And then 2015. And then we'll subtract 2010 from 2015, okay? So for 2010, we're going to have P of what? We're going to do P of 0. Some of you might say, what on earth? How did that happen? Remember, X is a number of years from 2010. So how many years from 2010 is 2010? 0 years, okay? So that's why x is 0. So you have 17 times 1.15 raised to the 2 times 0, okay? So this entire term here raised to the 0th power is going to become 1. Let me show you the steps. 17 times 1.15 to the 0th power, which is 17 times um, 17 times 1, which is just 17. Okay. All right. Now, 2015, that's P of 5. All right, P of 5, so that's going to be 17 raised to the 1.15 times 1.15 raised to the 2 times 5. Okay, now how did I get 5 for 2015? 2015 is 5 years since 2010. The difference in the years here is 5 years, so that's why x is 5, okay? So if you work that out, you have 17 times 1.15 raised to the 10th power. Well, we can have our calculator do the heavy lifting here. So let's go ahead and compute the difference. So we're going to do, for 2015 is 17 times 1.15 raised to the 10th power minus 2010 is simply 17, right? 17, and your answer is 51.7745, okay? So, well, let's just do this just to make everything nice. Let's show our work here. So for 2015, the answer is 68.7745. So this is approximately 68.7745. So let's answer the question. So we're going to say number of turkeys in 2015 than 2010 is simply the difference, right? So it's going to be 68.7745 minus 17, okay? And then when you compute the difference, you have 51.7745. So our answer is 3. We hope that makes sense. Think about turkeys. There's no such thing as 0.7 turkey. Is like an incomplete turkey walking down the street. That's strange. It's not possible. So in this case, you have to round down. When you're dealing with people or things that don't occur in fractions like turkeys, you're going to round down. So we're going to truncate this decimal piece. Our answer will be 51, option number 3. Okay? Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found this tutorial beneficial to you, do give us a thumbs up. We appreciate your positive feedback. Don't forget to subscribe to our channel for updates to the remainder of this review series and other cool math tutorials. If you have any questions, you can include a question or a comment in the comment section below, and we'll be glad to address it as soon as possible. More clips can be found on math.serve.com/testprep. Thanks again for watching and have a wonderful day.